Okay, so recording is started. So good morning, students. This is a class of geotechnical engineering. We are discussing about module 2, that is permeability of soil. So we have discussed till now about basics property of permeability, theory of Darcy's law. Okay, then discharge velocity or true velocity. Okay, or seepage velocity. We discuss about properties of that permeability, or you can say the effect factors affecting permeability, and also uh, some laboratory tests to determine coefficient of permeability of coarse grained soil and fine grained soil. Okay? And what are the tests? That is constant head permeability test and falling head permeability test. So two laboratory tests are available. We can conduct to find out coefficient of permeability for coarse grained soil and fine grained soil. Which one is for coarse grained soil and which one is for fine grained soil? It is already discussed with you students, and if you still have doubt, you can go back to the last class, or you can also search in Google or any search engine. You will find out which particular test is done for what type of soil. I will not tell now. Okay, if you forget, you can cross check your previous class notes or previous class recording video. Okay, so today even in the last class we have discussed about stratified soil, isn't it? Okay, let me first share my screen. Okay. Let me check whether it is here or not. Okay. Okay, in the last class, is it visible? Please respond to, is it visible, right? Okay, so in the last class, I'm just giving you some just overview, okay, of the last class. So in the last class, we have discussed, if I am not wrong, we are discussing about stratified soil deposit. Okay, we have defined, we knew that what is stratified soil. It is a combination of layer soil. Okay, it is a combination of soil layer having individual soil property. Even each layer have its individual coefficient of permeability. Okay, so they are known as all together is a stratified soil. And for stratified soil, coefficient of permeability depend. The average coefficient of permeability depends on the direction of the flow. That means we have a two case. That is, case one is what? When the flow is parallel to the bedding plane. And the second is what? When the flow is perpendicular to the bedding plane. So we have derived two equation, isn't it? Okay, let me first give this okay. So we have derived two relation, or you can say the equation to find out average coefficient of permeability for stratified soil when the flow is parallel to the bedding plane, and this is the equation k1 z1 plus k2 z2 plus up to kn zn divided by the total thickness of the layer, that is z, and z is what? Z1 plus Z2 plus Z3 up to Zn. How many layers are there? It's based on the problem. Okay, so we discuss about this. And secondly, secondly, this is your second case. That is coefficient permeability of stratified soil when the flow is perpendicular to the bedding plane. Okay. Now, even from the drawing, if I minimize this, even from the drawing, you will have an idea about that when the flow is parallel to the bedding plane, you can see two overhead tank are fitted along the direction of flow. Okay, along the bedding plane, you can say. So that's why water or discharge coming through this. Okay, and at the same time, that is at the time t equal to 0, the water is distributed into each layer. Okay, and in this case, that means when the flow is parallel to the bedding plane, in this scenario, for stratified soil, your hydraulic gradient will remain same throughout the process. Okay, water is flowing from left to right since this is at the higher elevation, and what is the head difference is h, isn't it? Head difference is h, and what is the hydraulic gradient? I is equal to what? I is equal to hydraulic head divided by the length traveled by the water, or you can say h by l. I is equal to h by l, and in this case, that means when the flow is parallel to the bedding plane, I remain constant. Okay, that means I for layer 1, layer 2, layer 3, layer 4, whatever layer, when the flow is parallel, hydraulic gradient will remain constant. Okay, but uh, since we know as per Darcy's law, visibility Ki, I is constant for each layer, but since it is a stratified soil having containing individual layer or individual property and coefficient of permeability, this K is a property of an individual soil layer and K will be different for each layer. So we can say although hydraulic gradient is same for each layer, but since K is different for each layer, your velocity of flow will also going to be different for each layer. That means the discharge velocity, or you can say the Darcian velocity or theoretical velocity is going to be different. So that's why V1, V2, V3 up to Vn. Okay. So this is the condition for flow parallel to the bedding plane. Okay. But when you discuss about perpendicular flow, that means when the flow is perpendicular to the bedding plane. Now you can see the difference. The arrangement of the stratified soil is same in this along the horizontal direction only, but the fitted of the water entry and exit are in a cross-sectional direction. That means in a perpendicular direction to the bedding plane. So since H is the total head difference due to which water flowing through its layer or through the layer, water is flowing from in this direction and finally from bottom to top. That means from bottom it will go upward since it is in a higher elevation. It's very simple to understand, right? And in this case, what are the condition? You have to remember the discharge is going through in this direction, vertically upward. And at first, this water, whatever water is coming through this conduit or pipe, it will first enter the bottom layer. Then after that, it will go to this second bottom layer, and like this, it will go upward direction. It is completely different from this first case. In the first case, that means in the first when the flow is parallel to the bedding plane, your Q, that means water uh, distributed to each layer at the same time. But it is not the case for the perpendicular flow case. Okay, at the in this scenario, water flow through layers one by one, not at the same time. Okay, that's why you can say each soil layer having different coefficient of permeability also have different hydraulic gradient. Okay, that means the hydraulic gradient or hydraulic head, you can say the H or H1, due to which water flowing through the first layer is not same with the H2 for layer 2 or H3 for layer 3 or Hn for a layer n. That means the hydraulic head will be different for each layer. But finally, the total head due to which water flowing through the whole layer, it is H. So we can say the H, that is the total head loss denoted by small h, can be written as H1 plus H2 up to Hn, where H1 is what? Hydraulic head for layer 1, H2 is a hydraulic head for layer 2, and so on. Okay, and for this layer, for this case, your velocity of flow is going to be constant for all layer. Now you can see the difference between these two. It is completely opposite condition. Okay, so you have to differentiate between the case 1 and case 2. Okay, don't mix up. In the case 1, your hydraulic head or hydraulic gradient is going to be constant, but velocity is going to be different for its layer. But in the perpendicular direction of flow, that means the second case, your hydraulic gradient is going to be different, but velocity is going to be constant. And finally, after going through the derivation, all these things, it is very simple to understand. Just go through the equation. Okay. After finally, you will get the average, will get the equation or expression for average coefficient of permeability in vertical direction. Okay, or upward direction. That means denoted by kz. Kz equal to z divided by z1 by k1 plus z2 by k2 and so on. That means z represents your total thickness of the layer. Z1, Z2, Z3 are what? Individual thickness of the layer. K1, K2, K3 are the individual coefficient of friction, individual coefficient of permeability for each layer. Okay. Sometimes this kz also denoted by kv. Don't confused. Okay, they are same. kv, v for vertical. Okay, v for vertical, z for z direction. Even this kx sometimes represented by kh, h for horizontal. Okay, so don't get confused. Kx is same as kh, kz is same as kv, vertical or horizontal. Okay, so finally today we're going to discuss some problem on numerical based on these two condition of stratified soil. Okay, so okay, let's close this PDF. I'll now open the numerical one. I think it is visible to you, right? Okay. So if you can see the problem statement, it is given as what? What is given here? First case is given as a stratified soil deposit consists of four layers of equal thickness. The coefficient of permeability of the second, third, and fourth layers are respectively one third, half, and twice of the coefficient of permeability of the top layer. Compare the average permeabilities of the deposit parallel and perpendicular to the direction of the stratification in terms of permeability of the top layer. So it's look like complicated statement, but it's very simple problem. Okay, just you need to draw the diagram and you have to uh, you can understand this particular problem. And usually this kind of problem usually asked in competitive exam. Okay, because this you need to remember the formula for flow parallel to the bedding plane and when flow is perpendicular to the bedding plane in case of stratified soil only. Okay, so here what is given? A stratified soil having four layers, that means 1 2 3 4, that means four layers are there. Okay, and the coefficient of permeability of the second layer is one third of the first layer. That means you can say, suppose for the first layer in the solution it is given as, say, or let the thickness of the top layer is given as z. Okay, or you can say z1, you can also write z1. Okay, and say coefficient of permeability of the first layer is k1 or simply k. Okay, now as for the given condition in the problem this statement, this k2, that is coefficient of permeability of the second layer is one third of the first layer, so one third of k. Coefficient of permeability of third layer is half of the first layer, so k by 2. Coefficient of permeability of the fourth layer is twice of first layer or top layer, so twice k. And generally the first layer is equal to k. So from the problem statement you will get this condition, that is k1 equal to k, k2 is equal to one third k, k3 is equal to k by 2, and k4 is equal to twice k. It's simple, and just I have plotted mathematical representation of the statement. After that, very simple, only you need to find out coefficient of permeability in x direction or horizontal direction, or and coefficient of probability in z direction or vertical direction. You just have to remember the formula. What is the formula? K1 Z1 plus K2 Z2 plus K3 Z3 up to K4 Z4 divided by total thickness of the layer. So what is the total thickness of the layer? Since it is given as stratified soil deposit having four layers of equal thickness, that means each layer having equal thickness. If top layer having thickness of z, all layers should have z. That means z plus z plus z plus z. That is four z's are there. So total thickness will be 4z. Okay. And here for first layer, thickness multiply first layer coefficient of permeability, like so on. And after solving this, you will get this value. After solving for vertical flow, you will find this value. Okay. Simple as that. You just try to find out by yourself, by your hand. Okay. After getting this, I'll also share this PDF also. After getting this problem statement, you just write this problem and solve this by your hand only. Okay. Okay. Next one. I'll just go to the next one. It's very simple to understand. And this question came in civil service. Okay. So engineering service, your 2002 question. So here it's asked to find what will be the ratio of average permeability in horizontal direction to that of vertical direction for a soil deposit consists of three horizontal layers. If the thickness and permeability of the second layer are twice of those of first layer, and those of third layers are twice of those of second layer. Okay, so it is the maybe a language may be complicated, but as well the first problem statement it is also very simple. Okay, just try to concentrate on each and every line in this problem. You will find the answer very easily. Okay, so here it is given as say K1 and Z1 are uh, coefficient of permeability and thickness of the first layer. Now just you have to follow the conditions. For the second layer, it is given as um, if the thickness and permeability of the second layer are twice of those of first layer. That means the coefficient of permeability of the second layer is just twice of the coefficient of permeability of the first layer. That is K2 equal to twice of K1. And for thickness also, the thickness of the second layer is twice of thickness of the first layer, twice Z1. Now, again, second case, those of third layer are twice of those of second layer. That means coefficient of permeability of the third layer is twice of coefficient of permeability of the second layer. That is twice K2. Okay. Now just put the value of K2. What is the value of K2? Twice K1. So simply you will just multiply 2 into 2. That is 4K1. Same way for thickness also. Okay. After getting this value, you can find out the total thickness of the layer. Since it contain what? How many layer? Let's find out how many layer. 3 layers. Okay. Since 3 layers are exist in this particular stratified soil. So Z equal to Z1 plus Z2 plus Z3. Okay, but what is Z2? Z2 is equal to twice of Z1. What is Z3? Z3 equal to 4 of Z1. Okay, so finally 4 plus 2 plus 1 that is 7Z1. So total thickness of the layer is 7Z1. So just into put the value in these two equations, find out KH for horizontal direction, KV for vertical direction, and after that, what you are asked to find out? What will be the ratio of average permeability in the horizontal direction to that vertical direction? That means you need to find out KH by KV. Just divide this ratio, you will get this value. Okay. Try this problem by your hands. Okay. Is then only you can understand. You just draw the diagram and show the thicknesses. Okay. It's then it will be easy to understand this particular problem. Okay. But it is very easy to understand. Okay, so this is all about today class. We have discussed some numerical on stratified soil. Next class we'll discuss about seepage of soil. Okay, that means Laplace equation, flow net. Okay, stream function, potential function. So all these things will be discussed in the next class. Okay, चलो ठीक है then. So I'll close my uh, sharing. Fine. So is there any doubt related to this problem? You can ask me if you have any doubt related to this problem. And if you don't have any doubt, then I'll just take attendance now. Okay. 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 Please respond to a call. Okay. I'm going to uh, take the attendance now. Okay. First of all, let me stop my recording.